Hello people. Things are getting weirder and weirder and weirder still. This morning I made a brand new repo that's basically it was born out of idea of this Taken's algorithm that can it can take 1D signal and blow it up to other things. We can basically you can take music, turn it into a what the actual scientist guys call attractors, mathematical attractor in space, and then it can turn it back. And now, what is brain full of? Brain is full of these attractors, but so takens in, takens out. The idea here is that, first of all, Taken's algorithm is very exact thing that works according to this guy called Takens who made it in the 80s. And but neurons, they have these dendrites that are have a specific link to the other neurons, and there's a reason why they're growing as you are thinking, um, very fast. But so that's kind of like our Taken's algorithm. So brain is doing these sorts of things and firing, and there's a 1D signal moving down the. So there's this is firing, the signal goes down the line, and so if there are things like this happening, first of all we can look in there because as these things are firing, we are getting the thing out of sequence. So you have multiple neurons firing at the same time. We are getting a blur, and the skull is that thing that blurs everything. So we get this hocus pocus thing of this massive amount of neurons firing at the same time. But so takens in, takens out was that we are taking a signal in, we are taking a signal into our brain, we have wires, the thing is firing, the signal is traveling down the line, and at some point perhaps the signal is re-expanded. And I mean, like simple ideas, I guess. Well, not really very complicated, and I'm not really following very well. But I know that we got let's see if I have the code. Let's solve them kind of one at a time. Let's see. So we had audio here somewhere. So this whole thing, this is all here. I actually haven't shared what just happened, and I'll show you the latest thing, which was completely and utterly mind-blowingly weird. Um, so I'm trying to see what relates to the audio. I had a audio to here somewhere. GD PNG, trying to find the audio, and I often notice when I'm looking at this afterwards, I realize like, holy shit, it's there. How could you miss it? But it's here. No, no. What if it was the previous thing from this morning? No, it was not the previous thing. But so that we can reconstruct from the attractor, we can reconstruct the signal is what I'm trying to show to you guys. Oh god. Here it is. It is here somewhere. It wasn't the Monday. It wasn't the Psi. It is. It must be the harmonic arm bank. But I'll just show it to you guys because first of all, let's look at the. And it wasn't that. It's. I think it's the perhaps the 1D. Could it be really? Yeah, it's that. So we are giving it audio, it turns it into a attractor, and then we are deriving it from the attractor back. So this was the proof with audio. Okay, this works. It works. We can turn thing into a attractor, and and when you're looking into brain signal, these attractors usually we see these mathematical attractors, and they are like, well, there is attractors, they are whatever, blah blah blah. But okay, so now the problem is that if you want actual audio, we got the audio out of the brain using that kind of like nonlinear transfer function where we probably got the vibrations from the skull using that Japanese thing in the brain as a resonator thing, go knock yourself out. This, if anybody's listening, it worked. It worked. We got audio out of EG. But once again, we probably got the resonations from the skull surface, so not super weird. But anyway, so we get these attractors from the brain all the time. Any mathematical thing, I mean, like you can have stock market 1D signal, you can have this and that and whatever, and you get attractor. Attractor. I mean, like, sir, yeah, I mean, like, tractor, whatever. So it's like X, Y, Z, I guess, here, point at points, and who cares. But here, what we did, we were able to do that idea I had this morning. Take us in. So you get 1D signal, and you do inverse takens, you turn it into, so you have a signal geometry or whatever, you are turning it into 1D signal, which is basically just these neurons firing, da 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 da, they are firing and the signal is moving in the brain, very much like AI weights. But instead of weights, the way they are moving is, if you go look at this, well, I could just show you guys the code. So what are the numbers in the brain? Well, there are these loops. There are oscillations, and if you look at harmonic thing here, oscillations. If you have a certain amount of like this, I think the number here is 7 or something. You can actually count 1, 2, 3, 4, 5, 6, 7. So that big ring, 2, 3, 4, 5, 6, 7. So numbers are these loops in the brain, these oscillations, they are actually numbers. And if you one neuron passes it to the next neuron, so then they are integers. They are one under something, one under something. So suddenly we have weights. The neurons, they are able to calculate. Now suddenly everything starts to look very computational. I mean, like we have the complex signal in turned into these numbers, these harmonic things, and they are growing in real time to adapt to the signal coming from outside. Example, a baby is listening to the mother talk and learning to resonate with the mother speaking, and brains are locking and they are, hey, I think like my mother suddenly, and for some that's a good thing, for some it's a bad thing, but anyway, so I'm sorry about that, guys, wherever that came from, but anyway, so we get very AI-like thing. And then when we are listening to the brain, the problem is we cannot listen to the wires as in the like looking at the whole brain, all of the neurons. We can't do that. But then we suddenly have AI stack-like thing. The dendrite itself becomes like on the AI we have weights. These weights are usually two-dimensional. They are numbers, and the vector is shooting through them. But suddenly we have the signal is coming in, and there are these integers, they are doing the integrating thing, and there was ChatGPT said something that something neurons that do this together, wire together, like resonate together, wire together, or something like that. But okay, so but suddenly these attractors are something that we can decode if you know the system underneath. If we know the system underneath, we can't take it from the surface of the brain because we are just listening to the freaking radio channels of 80 billion neurons and the dendrites firing, and we get the summation and the blurry signal from the top. Sorry. But anyway, so okay, so what can we do with this? A while back I had a code called and let's go there, psi image, which was just fast Fourier transforms that I really didn't understand back then, and still kind of really not really and it's not here, is it? It's no, it's here. And what we just here what we did was something a little bit different. So we have fast Fourier transform. That's yet another one of these things that we are transforming. We are transforming image into a frequency, and when you are turning an image into a frequency, we found out that, like for example here, that the image is actually mostly in the low frequencies we get the gist, but if you go to high frequencies, highest frequencies, we get the so-called Nyquist limit, which here is 64, 64 chess patterns, mathematics. But here's the thing, suddenly we can think, if this is how things were, then those harmonic loops, these are numbers. Suddenly we have numbers. We have the neuron, okay, there is certain sort of a Nyquist limit, like certain sort of upper limit, lower limit, things are being written to, and we have in the middle, we have Moiré patterns, and these Moiré patterns perhaps may be the, let's not go there, complicated. Some mathematician here would be screaming, you cheaty idiot, and well, I am self-processed, that's not the word, self something idiot, I have hole in my brain. And autistic, interesting things, and that's why I'm playing it, things like this. But before it was maybe music, now it's kind of like this. But anyway, so, and maybe music still comes to be played. But so, okay, we have this thing. So what can we do with this? Okay, this was psi image, and probably I was still feeling the psi. And so, okay, today we have a new sort of transform. Like, what did ChatGPT say? Something that it's time in time or something like. Oh, let's see. Let's just look at the whole thing here. So we compare this to compare this to. So it's not like FFT. So what we had there with the psi image was fast Fourier transform. We are doing image to frequency, but also image has this like the fast Fourier transform. If you guys notice there's a weird kind of a little thing. Like if you load an image, it's global. So if I was to change these patterns here, it will change the global image. But this thing what we have with this attractor, it's sorry guys, it's not like really like this. The attractor thing, it's not local. Let's just read here. Not really even understanding. Perhaps I understood for 1 second, but so in FFT, if you move something, it would. It's geometry. It's geometry. It's geometry. It is geometry. And here, guys, I'm sorry, I'm even looking like an idiot, but I can't help myself. You're doing geometric interference over dynamical equivalence classes. So we are doing resonations. We are systems where attractor structure means something stable in the world. So when the attractor is something, the world is a certain way. And I was asking, like, okay, if you knew, like, in the brain or wherever, like, the attractors, what do they look like? Could we point that, hey, here's a attractor, I want to listen to it if this is sound. But of course it gets complex because if you put signal to a computer, I'll stop now. But anyway, so, but I had an idea. We had a psi image. Now, what if we have a psi image that uses attractor and we mess with the attractor? What happens? And weirdest thing popped out, which is why I started yapping. So, um, there, and let's see, here. So this is the psi image, but the idea now is that we take an image, we turn it to 1D, and we get this attractor, and then this attractor we use the Taken's algorithm to turn it back into a signal. The kind of a thing here is like the best thing to understand is that like when we are listening, the signal goes into the neurons are firing, they are treating it as 1D signal, but then when it's time to speak, we somehow our brain does this backwards process and we turn it back into sound in our thing, and it's somehow neurons have learned to do this trick, magical trick. You see a world, you got Well, you are in the grip, you're listening to a voice and blah 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 blah. You hear it, your brain connects. Okay, this is my voice. This is my mother's voice. And then slowly, you know, okay, they are saying dog. Okay, dog. Thing in my mind, and these are 1D signals, but you can see them. But you can also take them out. You can produce the signal, blow it up back into what you heard. But so okay, now the question: what if and we were in wrong folder, of course, right? Now, what if we take an image and turn it to a tractor? Um, this kind of relates to the VST we did yesterday in a way, but what do you see? We have 3D cube, and the X there is me in my world, and I can start moving in that world, and I can also change the delay. So arrow keys left and right change the delay, and up and down change the strength. And so okay, now I was changing the delay time, and you guys just see that. Okay, not really interesting, but so I can move in this. I can move this box here. Here we are around we are around 0. I think that's why we just have this 45-degree thing. But what happens when I start to increase the delay time? Suddenly we get 3D object, um, almost like a 3D scan. So it's almost like we are getting the signal. It's being blown back to 3 dimensions. Like, how is this happening? But then when we do the strength of the signal, and I think I'm somewhere in the middle now, so I moved a bit. I can move in this signal. Notice what happens. The image starts to, and here we are. Here we are in completely weird ass mathematical territory. I'm not claiming to understand. I know that I'm the X, and the real weird thing that my mind is jumping into. Of course, I'm an idiot, so do not listen to me. But what if we are kind of like in a tractor inside space? If you guys look, there is now suddenly there's a three-dimensional manifold around. I think I can zoom in. So imagine, guys, if we are inside our brain, and there the world is kind of like the borders. Here we are. Somehow this is happening in real time with the 20 watts our brain is using with the neurons, and it's doing these sorts of calculations. The thing that I did not get why. Do you guys see what's happening in the background in the lower images? So this is the when I am changing the attractor, it's changing the image. And what's happening, guys? It's like a kaleidoscope, right? First of all, we are getting what looks like, you could say that, hey, that's the sharpness, but it's not just sharpness. There's a phase coupling. If you guys notice, like suddenly I left myself behind there. If you see, there's three arms here. I'm leaving a copy of the image, am I not? At certain intervals. And another weird thing happened here is something that is this is relating to the thing that the image is 128, and somehow at 128, for some mathematical reason, we get a plane. So if you guys notice, this is a plane. When I turn it like this, it's a plane, and that there is some mathematical complex reason for it. But I'm trying to understand this system. The Moira system was kind of easy to understand, because once you figure out, so I'm moving up here, and you're seeing, so I'm messing with the tractor here. The Moira system is easy kind of to understand in a way that, well, hell, it's not easy to understand. What am I saying? But this is even harder to understand. This takes the cake. We are moving inside the tractor. We are moving inside the tractor, and as you guys see, the knot here is, we are tying some kind of a freaking knot inside the thing. And so if we are perfectly normal inside the thing, like the way The image first was, okay, here's just an image, here's just an image. We turn the image into the attractor, and we turn the attractor back to image, and we're now moving inside the attractor. Actually, I think kind of like what I am here is just some sort of a transformation point, but this is magical. This is absolutely magical. Like, what the hell is happening here? Like this, and why? Like, I'm getting a three-dimensional world. I mean, it makes sense if the takens can expand a signal into something else. Well, what if you do takens twice? I'm not gonna say anything. But yeah, this is why I started to yap, and I guess I'll share this with you guys, whatever its name was. Attractor side region. Like, can you? Okay, like there are many different ways of turning images into 3D, but usually they require many images. That's kind of a thing. But what would be the greatest thing here? I mean, like, of course, I don't know. Brain to computer interface, if you understand that, then I don't know if that's great, but and that looks so simple. Like, okay, we just get this thing. The image starts to revolve, but I think we get sort of a delayed copy of it. That's kind. So when I'm pressing down, we get this thing. But the thing that's in the background, that's kind of haunting. Like, whatever hell is there in the background? But yeah, the idea was just that, okay, if I have a side image where we are doing the FFT and I can see the Murray pattern, I can change it. Like, okay, what if we can turn things into a attractor, and we can turn the attractor back to image. Takens in, takens out. So inverse takens and takens. The same way there is inverse fast Fourier transform and fast Fourier transform. And in fast Fourier transform you can do it lock, transform, or non-lock, and let's not even go there, but whatever. So this complicated weird ass thoughts, as you guys see, I'm completely not really clueless, but utterly addicted on this stuff that I really don't understand. Anyway, I hope you guys saw that.